You can what? Sometimes the diagram can be allocated in half. Alright, so the first one, okay, so we start by doing A1. So our trig equation is sine 8 degrees equal to K. Alright, listen, I expect you to be able to control your talking. Okay? Now, the denominator of the K is a 1. And the numerator, it will be Y, the denominator will be R. Okay? I expect you to be aware of this from last year. Right? Then, we need to calculate X. Okay? So, R squared is equal to X squared plus Y squared. This is Pythagoras. So our R is 1, so that will be 1 squared equal to X squared, which you want, and then Y is K, so that will be plus K squared. So X squared will be 1 minus K squared, and X will be the square root of 1 minus K squared. Then, fortunately, in my case, I've got some shapes, but, well, let me use that like. So I can draw a nice triangle. Okay? And then I can label the 90-degree angle nicely. But it's not perfect. Okay. But I tried. Alright. So here, your reference angle is 8 degrees. Can you look on the board, please? Right? Always determine the other acute angle. So subtract this from 90, you get what? 82 degrees. Right? Because there are some times where you might need the other angle in your question. Okay? So once you have got this, your R here is 1. Then X, remember, is the horizontal distance. Y is going to be K, that's the vertical distance. And the horizontal distance is X. So that's 1 minus K squared. Once you have determined your three values, X, Y, and R, and you've drawn your diagram, everything else is going to require application of these skills here. Okay? Then, let's move on now. We want to determine what is sine 72. Okay? That's 72, isn't it? Oh, it's 172. Okay. So, sine 172 degrees. Now, since that angle is obtuse, right? We use reduction. So this is equal to sine 8 degrees, which is going to be equal to, now, sine 8 degrees is equal to K. So that will be straightforward. So this will be K. So this is A1. Then A2, you need cos 82. Right? So cos 82 degrees is equal to, now since on the diagram I've got cos 82, I'll just use that value. So we have our reference angle 82. This is the opposite side. That's the adjacent side. Since it is cos, cos will be adjacent over hypotenuse. So it will be K over 1. Sorry, can you pay attention? Okay, so this will be equal to K over 1, which is K. Then 3, we have cos 8 degrees. Cos 8 degrees, obviously this one is going to be x over r, and our x is the square root of 1 minus k squared over 1, which is the same as 1 minus k squared, right? Well, for this one here, the one you can write it, but it's not necessary, the answer should be that. Okay, then The next one is sine 16 degrees. Sine 16 degrees. Now, what's the relationship between the 8 degrees and 16 degrees? 16 is a what? A double angle. So you can write this one as sine 2 times 8 degrees, which is the same as 2 sine 8 degrees times cos 8 degrees. Right? I'm applying this. Okay? I'm applying the double angle there. Right? Fortunately, we know what sine 8 is. It's equal to k. Cos 8 degrees, we also know it's square root of 1 minus k squared. So our final answer will be 2k times 1 minus k squared. Okay? It's very straightforward. Alright? Are you following? Right? And then the next one is cos 16. Cos 16. Alright, just give me a second so that I can charge this laptop. Right, so cos 16 is also a double angle. So cos 16 is the same as cos 2 times 8 degrees. Now with cos, you are spoiled for choice here because there are 3 of them. So you can use any one of the 3. Any one of these 3 will give you the same answer. But what I would suggest is it's better to work with one trigonometric ratio. Right? In this case, I'll choose number 3. Okay, I like number 3 because I know that sine 8 degrees is k. So that will be 1 minus 2 sine squared 8 degrees, and this is equal to, right? Can I have your attention? Do you see why I'm choosing number 3? Yeah, to make things easier. Okay? So that will be minus 2 sine 8 is equal to k. So you get 1 minus 2k squared. Yeah, you still get the same. Okay, let's do it. Okay, let's do it. Let's say we use number 1. Okay? If we use number 1, it's gonna be cos 16 degrees is the same as cos squared 8 degrees minus sine squared 8 degrees. What is cos of 8 degrees? What is cos 8? It will be square root of 1 minus k squared, all squared. You have to square it, right? Sine 8 squared is going to be k squared. Alright? Then you get 1 minus k squared minus k squared. And this will give you 1 minus 2k squared. So you get the same answer. Okay? So in this case, you should be able to get full marks for the question because you are spoiled for choice. Right? Then, the next one is sine 68. Now, sine 68 becomes problematic because our diagram doesn't have 68 degrees. Okay? But you have done compound angles, double angles, also special angles. Okay? So we can break it up into sine 60 degrees plus 8 degrees. Okay? Because of special angles and compound angles. Some of you are not paying attention. Do you know that last night I just, you don't know, but I'm telling you now. I set your paper already, the formal assessment. It's almost like 80% complete. Alright? Okay? So let's carry on. Last night. Today I'll do the last part, the 2D and 3D problem. Alright. Let me carry on. So this will be sine 60 degrees. But some of you, for some reason, I don't know why you lose concentration or whatever. So compound angle, number 2a there. So this will be cos 8 degrees plus sine 8 degrees cos 60 degrees. Are you following? Huh? Right, this will be equal to square root of 3 over 2 times cos 8. Now cos 8 is square root of 1 minus k squared. Right? Plus k times a half. So we can put a half there. Right? Then, right, now this becomes interesting now. So we can write this as square root of 3 over 2 times the square root of 1 minus k squared plus k over 2. Okay? Then I can just write one thing as my final answer, which will be square root of 3 times the square root of 1. In fact, I can put this square root. I can put it inside. Okay, let's simplify and put it inside. So it becomes the square root, but you have to know your sets very well here. If I take this 3 into the root, it will end up getting 3 minus 3k squared. Because you have to multiply with what's inside. This is all over. Okay, that will be plus k all over 2. So that will be your answer. Okay, now it's very possible sometimes that questions like this, you can get a very complicated expression as your answer. It's very, very possible. Okay, so a question like this one here, it will have probably 4 or 5 marks. The only that sine 68, because it requires a lot of things to actually do.
So what are the chances?
The what?
What are the chances?
Well, normally it comes as a higher order question. If you are to get a question with a ratio which is a letter, it can come as a higher order question. Alright. Okay, any question? Is anybody who has got a question? Huh? Alright. I can't. Okay, how many of you have done it? Number 9. Okay, I'll give you an opportunity to try it out. Those who haven't done it. So this is tan 196. The moment you have an angle which is not acute, reduction. Okay, reduction straight away. So this is the same as tan 16 degrees, because 196 is in the third quadrant. And in the third quadrant, tan is positive. Then, if you look at the diagram, we don't have 16 degrees. So you have to convert tan to sine over what? Over cos. So it will be sine 16 over cos 16. Then your double angle will kick in now for sine and cos. But I think we already have the answer for sine 16. What was the answer? 2k squared? 1 minus k squared. All over. 1 minus 2k squared. Like that. Right? Now, we can take the 2k into the root. You know that it? Yes. Then it becomes what? 4k squared. Right? Now, it depends now whether the question wants you to simplify it completely or not, but as it is right now, it is simplified. So you might not have to simplify it any further. Okay? But let's say, okay, please, I'm just going to do this for interest's sake. As it is, it's fine. Okay, yes, you get full marks. So if I take the 2k into the root, because the problem is how to remove the root. You cannot remove it. Okay? You do not remove the root, unfortunately. And the denominator also is not a difference of 2 squares. So if I can write it as the square root of 4k squared minus 4k to the power of 4. If I take the 2k into the root. This is all over 1 minus 2k squared. Okay? Then I've got a difference of 2 squares. Okay, if I take out a common factor, I can take out a common factor, but it won't help me. Okay, it won't help me. So for this question here, I would suggest that you stop there. Stop here. Because you cannot remove that root. Okay, you want to remove that root. Are you following? Right.